Welcome back at Cisco. In this lesson, we're going to talk about trigonometric ratios, and I said here they are very useful, especially if you need to find missing sides and you have just one side and an angle, not two sides. If you have two sides, obviously you can use what we call Pythagorean theorem. But first of all, let's see a couple of things that are important about trigonometric ratio. We call them adjacent leg, of opposite leg, and hypotenuse. I said here it's very important to identify this correctly. So what do you mean? Let's take a look here. You see this angle B? For this angle B, this leg BC is what we call the adjacent leg, which I will put it in the short form, adjacent leg. On the other hand, this is opposite leg, is on the other side, okay? And this is the hypotenuse. On the other hand, for this angle D, what will be the adjacent leg? The adjacent leg will be DE next to angle D. That means the adjacent leg. The opposite leg will be EF, and the hypotenuse is this side, the longer side on the other side of the right angle. And sometimes you're going to have a triangle that is like that, is the same way. The opposite leg of this angle G will be HM, and the adjacent leg will be GH, and this one will be the hypotenuse. So now we can define the first trigonometric function, the ratio, which is called sine, which is the ratio of the opposite leg and the hypotenuse. So let's take a look here, and we have the same triangle like in the previous picture, but now we're going to write sine of B, which is nothing else than the opposite leg, which is AC, over the hypotenuse. Here, hypotenuse is this side, which is on the other side of the 90-degree angle, so AB in this case. What about this angle D? Sine of angle D will be, what will be the opposite leg? That will be EF in this case. You see, is on the other side of the angle, and the hypotenuse is DF. And if you remember, we have a third triangle. This one, if you get a triangle like that, it's the same way. Let's say you want to write sine of G, the opposite leg, you see I already drew the arrow, it's going to be HM. The hypotenuse is GM. The next trigonometric ratio is cosine, which is nothing else than the ratio of adjacent leg and the hypotenuse. So let's take a look. The same triangle, cosine of B now. That will be the adjacent leg, BC, over hypotenuse, AB. Cosine of D, that will be what? The adjacent leg, DE, over the hypotenuse, which in this case is the side DF. And for angle G, cosine of G will be what? Opposite leg now is HM. I'm sorry, we need to start with the adjacent leg because we have to talk about the cosine. So the adjacent leg will be GH, and the hypotenuse is GM. The last trigonometric ratio in this lesson is the tangent. Tangent is defined as opposite leg over the hypotenuse. So let's take a look to this picture. Again, we have the angle B, so we have tangent of B, and that will be opposite leg. What is the opposite leg? AC. What is the adjacent leg? BC. What about the angle D? Tangent of D is, this is the angle opposite leg, EF. Adjacent leg, DE. And the last triangle will be the tangent of G here. Tangent of G, opposite leg, HM. Adjacent leg, GH. This is a short way to remember this trigonometric ratio, SOHCAHTOA. And if you notice, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite leg, adjacent leg. And you see that also here for this example. So now let's try to do this problem where we are asked to find the trigonometric ratio of angle T. So we're going to start with sine of T. And if you remember, sine is opposite over hypotenuse. So that in this case, for this angle T, will be 12 over 13. What about cosine of T? If you remember, cosine of T, cosine of an angle is defined as adjacent over hypotenuse. The only thing you need to be careful. So I'm going to erase here the same angle, right? So cosine is adjacent 5 over hypotenuse 13. The last trigonometric ratio, tangent of this angle T. Tangent is defined as opposite leg over adjacent leg. So you notice now here SOHCAHTOA, what I just said the previous slide. So let's see in this last trigonometric ratio what the ratio is. From the angle, I'm going to go first to the opposite leg, which is 12, and the adjacent leg, which is 5. My next part of the lesson, I'm going to use this trigonometric ratio to find missing parts, like this example we have here where we said find the value of x, round it to the nearest tenth if needed. So we have this triangle here, we need to find this x, and if we notice we have the hypotenuse and we have an angle given to us which is 33. So I'm looking, I will always start from the angles. I'm looking and I see what? Angle. I'm looking for the hypotenuse, I'm sorry, for the opposite leg, and I have the hypotenuse. So I have to find the opposite leg. I know the hypotenuse for that angles. Which trigonometric ratio works with opposite and hypotenuse? That will be sine. So I'm going to use here sine of angle T, which is 33 degrees, equals opposite, which is x, over hypotenuse, which is 24. So how do we solve this equation in x? I will multiply by x, by 24, to get rid of this 24. Of course, you want to do that here to keep the balance. So x will be 24 sine of 33. This is the exact answer. If we need to evaluate, round it to the nearest tenth, we're going to need a calculator. So I'm going to grab a calculator and depends on your calculator how you put it in. Let's see how much we get. I end up with 13.07, and if I round it to the nearest tenth, that will be 13.1. So the exact value and the rounded value. So this was part A, and part B was very similar problem, but you notice a difference. Now x is right here. It is the hypotenuse, but we know the opposite leg of this given angle. So again, you hear opposite, you hear hypotenuse. That should bring again the sine. This is the second case where you use sine. You'll see it's going to be similar, however different. So I'm going to write again sine of the angle T, which is 33, equal, again, opposite hypotenuse. Now I'm going to have 24 here on the top of the fraction numerator over x. So like I said, very similar, however different. The process of solving, again, very similar, at least in my case. I'm going to multiply by x to get rid of this x. Don't forget to do that here. So we get x times sine of 33 equals 24. And then I will divide by sine of 33. Obviously, you have to do that on both sides. And the exact answer, I'm going to put it here, is, in this case, 24 over sine of 33. If you need to evaluate to the nearest 10, like I said, you're going to need again a calculator. Again, be careful how you put it. 24 divided by sine of 33. I end up with 44.06. I'm going to round it to the nearest 10, so that's going to be 44.1. In this problem, the answer needs to make sense. Take a look to your answer, and eventually, like I'm going to show you here, this is 44.1. That makes sense, is reasonable, is longer than this 24. This is the hypotenuse. And here, 13.1, yes, that makes sense, is less than the hypotenuse, which is the longer side. So you may want to check if you have the wrong setup. Probably you can see that based on your answer. Let's go to the next example. On this example, we notice what? We have the angle. We're looking for the adjacent leg, and we have the hypotenuse. So again, if you remember, I said adjacent, hypotenuse. Which trigonometric function use adjacent and hypotenuse? That would be cosine. So here I'm going to have cosine of 27 equal, again, adjacent x over 14. Very similar with a previous case, but I'm going to multiply by 14 now, so I can get rid of this 14. So x will be 14 cosine of 27, which is the exact answer. Now, if we need to find a value, evaluate a value to the nearest 10, we're going to need a calculator. And I'm going to get 14 times cosine of 27. I end up with 12.47, so I will say 12.5 because I want to round it to the nearest tenth. Again, you notice this value is less than hypotenuse, which I think is a reasonable answer. Let's take a look to the second case, part B in my slide here. And this one will be also cosine. Why? Again, we notice the angle, the adjacent leg is given, and we're looking for the hypotenuse. Again, you notice I said we have the adjacent leg, we have the hypotenuse in this picture. We're looking for the hypotenuse, so that requires the cosine. So this is the way I identify the function. The ratio cosine of 27, this case equal, adjacent now will be the 14, and the hypotenuse will be x. So very similar, however different, because now x is the denominator. I'm going to solve it like in the previous problem. I'm going to multiply by x first to get rid of this x, which is okay because x cannot be 0. So we have x cosine of 27 equals 14, and I'm going to divide by cosine of 27 now to solve for x. So we have x equals 14 over cosine of 27, which is the exact answer, like I said in the previous problems. Now we're going to evaluate, and again, be careful how we do it. 14 divide now by cosine of 27, and that will be 15.71, so I will round it to the nearest tenth, 15.7. Again, if you take a look here, it does make sense. This answer, this hypotenuse needs to be longer than the leg, which is 14. Let's take a look to this example where we have a very similar picture, but however you will notice we're going to use a different trigonometric ratio. Why? We have the angle, we're looking for the opposite leg, and we have the adjacent leg. So again, if you heard, we're looking for the opposite leg, we have the adjacent leg, so that tells me I'm going to use the tangent. Okay, tangent of 38 of the angle T equal, now again, opposite leg over adjacent leg, x over 23. Multiply by 23, very similar to the other problem. To get rid of this 23, I'm going to multiply by 23 the other side, so we have the exact answer, x equals 23 tangent of 38. Again, if we need to evaluate, a calculator, and we're going to have here 23 times tangent of 38, and that is 17.96. That is an interesting answer. If I round it to the nearest 10, that will be 18. Again, now we're looking on this one. It's kind of hard to see if it's reasonable, but I will say this. You see, this angle is 38. Yeah, that is reasonable for me as a math teacher. Yes. Let's take a look to case 2. In this type of problem, part B, again we notice the angle, but now we looking for the adjacent leg, and we know the opposite leg. So again, we here opposite and adjacent, that again requires the tangent. So we're gonna have now tangent of 38, but now be careful, opposite is 23, adjacent is x. So now I'm gonna do the multiplication by x like in the previous problem. Which is gonna give me x tangent of 38 equals 23, divide by tangent of 38. So we have the exact answer. X is 23 over tangent of 38. Now if you need to evaluate, again the calculator, 23 divided by tangent of 38. I end up with 29.43, so I will round it to the nearest tenth, and that will be 29.4. Now we have this situation where you notice we have two sides and we're looking for the angles. Whenever you have something like that, you're going to use what is called the inverse trigonometric ratio. And I put them here in this format because that's the way you're going to see it on your calculator. There are some other alternate form that probably you're going to learn in your classes. But let's see how this problem works. And it works very similar with the others we have. Now I'm looking for this angle, but I know this opposite leg and I know this hypotenuse. So again, if you remember, I said opposite and hypotenuse. So which trigonometric function use opposite and hypotenuse? That will be the sine. So again, I'm going to use the sine. The only difference I'm going to say now, sine of the angle t, which is x, the value we need to find, equal opposite 21 over 35. So now how do you find x? It's just the calculator. I'm going to write here the exact solution, which is this one, and look at here how I write it. And I will put the parentheses. I will suggest you to do the same. And this one here says x is the angle for which the sine is 21 over 35. The only way to find it is by using a calculator. Again, that is the exact solution. And you can leave it like that in case you need that. But then be careful how you put in the calculator. Depends on the calculator. Mine, it's gonna tell me in a second how much that is. The angle for which the sine is 21 over 35 has a measure of 36.86. I'm gonna round it to the nearest tenth, so I'm gonna say 36.9. So this is a evaluation to the nearest tenth. This is the exact value. Let's take a look to this example. Very similar. We're looking for an angle x. We know the adjacent leg and we have the hypotenuse. So again, adjacent leg, we have the hypotenuse, the trigonometric function ratio that connects adjacent and hypotenuse is cosine. So I'm going to write here now cosine of x equals adjacent is 22, hypotenuse is 70. So now how do I find x? I'm going to use the inverse trigonometric ratio in the calculator. But this is the exact value. Just copy like this and just put that -1, which is, by the way, is not a power, is a notation. Okay, this one means the angle for which the cosine is 22 over 70. So let's see how much that is. Again, like I said, the calculator. I end up with 71 degree 0.68. So 71 degree 0.7, because I will write it to the nearest tenth. This is an evaluation. This is the exact value in this case. And by now I think you know this is the last case. Let's see what the trigonometric ratio will use. We're looking for the angle. We have the opposite leg, we have the adjacent leg. Again, opposite, you heard, and adjacent, that will be the tangent. So I'm going to have tangent of x equal 17 over 46. The exact value will be x equals, again, d notation, if you remember, tangent, d is -1, 17 over 46. This is the exact value. If I want to evaluate, just the calculator. So we're gonna have an angle that is 20 degrees, 0.28. So I'll round it to the nearest 10, 20 degrees, 0.3. Trigonometric ratios are very useful, especially when you want to do real-life application involving indirect measurement. Like in this case, a skateboard ramp is 14 inches high and is rising angle of 17 degrees. How long is the base of the ramp? Round to the nearest 10th. So let's make a picture. This is the skateboard ramp, which is 14 inches high. It rises at a 17 degrees angle, and we need to find how long is the base of the ramp. I will say this x here, the base of the ramp. So now we look into this picture I have. We notice the angle. We have the opposite leg, and we're looking for the adjacent leg. Opposite leg, adjacent leg, that will be tangent. So we have tangent of 17 equals 14 over x. I'm going to multiply by x here, and I have x tangent of 17 equals 14. Divide by tangent of 17, and this is the exact answer. Let's evaluate this, and that will be 14 divided by tangent of 17. I end up with 45.79. Round it to the nearest tenth, that will be 45.8 inches. In the last part of the lesson, we will look to something that is called solve a triangle. And I said here there are two cases. We're going to take a look to the first case, which you see it here. The first case you see here, we have the two sides. And solving a triangle means to find the other parts of the triangle. The third side, in this case, this one, and the angles. So how do we find the side? We can use Pythagorean theorem, and we're going to have, if you remember, a squared plus b squared equals c squared. A and b are the legs, so in this case we have x squared plus 7 squared, and you can switch this guy, that's not a problem. C, be sure, is the hypotenuse, 9 squared. So we have here x squared plus 49 equals 81. We're going to subtract 49 on both sides, and we end up with 32. So x, the third side of the triangle, which is nothing else than GR, will be square root of 32. This is the exact value. If you want an evaluation, of course you need a calculator. By the way, this one can be simplified as square root of 16 times 2, so that will be 4 square root of 2, in case you need that. In the calculator, we're just going to put square root of 32 and see how much that is. Okay. I'm looking in my calculator for square root of 32. And I cannot find it. I found it finally, so that will be 5.6 rounded to the 6.5, so that will be 5.7 if we round it. Okay, so now we can move to the next thing. We need to find the angles, and we're gonna start with any angles. Let's say you start with this angle G, and I will suggest you to use the pieces we have. We can use this 5.7, but we're gonna have more errors. So we look into this angle, and we have the opposite and the hypotenuse. So I'm gonna say sine of G equal 7/9. For finding this angle, of course, I'm going to use the inverse trigonometric ratio. So the measure of angle G is going to be sine, the inverse, the arc sine it's called, in fact, of 7/9. So now the calculator is going to give us the value. I'm going to ask the calculator to give us the angle for which the sine is 7/9. That will be 51.05, so I'll say 51.1 degrees. And we need to find one more part, so we have this one, 5.7. We have this angle, 51.1. And by the way, in the calculator, I have it with all the decimal. The last thing you need to do for finding this angle T, subtract what you have from in your calculator from 90, and I end up with the measure of angle T is 90 minus the measure of angle G. So like I said, I already have it in the calculator, and that gave me 38.94. So I'm going to run it to the nearest 10, and that is the measure of angle T. And now we know everything we need about this triangle. We solved this triangle. We knew only two sides, but we are able to find the third side and the two angles. So this is case 1. We have a case 2. You notice here we have the angle given and the side. So the first thing I will say, you can find these angles T. The measure of angle T will be nothing else than 90 minus the measure of angle G. Remember, these two angles are in interior angle of a right triangle. They are complementary, so we have 90 minus 74, and that will be 16 degrees. Now we're looking to find the missing sides, and again here I will use the information we have. We have the angle, we have these opposite leg, and let's say we want to find the adjacent leg. So I'm going to use the tangent of angle G, which is 74. That will be this RG. let me call it x here, over, I'm sorry, it's going to be 10 over x, opposite leg over adjacent leg. So again, I use the tangent. Tangent is opposite leg over adjacent. I'm going to solve for x here, so I'm going to multiply by x like we did in the previous problems. I have x tangent of 74 equals 10. I'm going to divide by tangent of 74. And this is the exact answer for RG or X. The only thing you want to do now, since we need to evaluate, grab a calculator. I end up with 2.86. And I'm going to round it to the nearest 10, 2.9. That's his RG. Now, you need to find the third side, the hypotenuse of this triangle. You can use Pythagorean theorem, you know this 2.9 and this 10, but I think the best way is to use trigonometric ratio, and I'm going to use the same angle G, but obviously we can use this angle because now you know it. So if you don't like to use G, you can use T, which is 16. But now let's take a look. We know the angle G, but now we want to find what? We want to find this hypotenuse, and we know this opposite leg. So again, you heard opposite leg and hypotenuse, that will be sine. So we're going to have sine of 74 equals 10 over, and I'm going to call this one y. Don't call it x, I guess. And the process is the same. Multiply by y. And divide by sine of 74 on both sides. So in this case we have y equals 10 over sine of 74, which is the exact answer, and this one is nothing else than the hypotenuse, which is TG. If you need to evaluate, which we are asked around to the nearest 10, you'll need a calculator, and we have 10 divided by sine of 74, the up with 10.4. Okay, I want to emphasize that this is not the only way to do it. This problem and the previous problem, you can play with different trigonometric ratio and Pythagorean theorem. If you enjoy this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.